So welcome everyone to CCS Technical Workshop number 2. We have primarily one topic to show you today, and that is the demonstration of some of the software that has been developed to implement the reference architecture, the proposed reference architecture in CCS. And we will show you this this demonstration that Ulf has prepared, and after that we can have some discussions and questions. So let's get started on showing this. Let's see, you can get it on screen. One second. Let's see. It's full screen.
Hi, my name is Ulf, the strategist at Geotab. I've been involved in the CCS project for about 2 years, where I've been heavily involved in the implementation of the communication stack between the vehicle and the cloud. And in the CCS projects, we are trying to implement the reference implementation of an architecture that looks like this, where we have vehicle and vehicle solution for capturing vehicle data and transporting it up to the cloud and to a database in the cloud. This database can then be accessed by the backend framework that can generate interesting insights from this data and services that can be built upon this data. I will demo this part of the stack between the vehicle and the database in the cloud, which is what I've been involved in implementing also. I demoed the same communication stack on the last AMM last fall. Then we had a vehicle client that was using VISS and the HTTP protocol to pull data from the VISS server in the vehicle and write it into the OVS database. This time we will extend this a bit and have not only one client pulling data using HTTP GET, just as on the previous demo last fall, but we will also have 2 more clients. One that will use the VISS, the other VISS protocol that is standardized in that coming standard, the WebSocket transport protocol, over which it will do subscriptions to the VISS server that will then push the data to the client, and that will then write it into via the server into the database. And we will also have a third client that will use the MQTT protocol, or actually it adds a small application level protocol on top of MQTT to be able to run the VISS protocol over MQTT. And this is still an experimental alternative that might be added to the VISS standard, but is not yet decided. And it will use then this do subscription, just as it's done here, but over WebSocket it will do the same sort of subscription, but over MQTT and via, of course, an MQTT broker. The vehicles will not be real vehicles here, but we will simulate the vehicles and simulate the data. And that simulation will look like this. We have the VISS server that gets requests from a client, and the server will then retrieve the data according to the request from a SQLite database that we call state storage database. This is just a buffer in between the server and the underlying system that will only keep the latest data sample of all the different signals that it supports and is defined in the VSS tree. Instead of having a real vehicle writing into the state storage, we have here what we call a live simulator that actually retrieves data from an OVDS populated or pre-populated OVDS database, and then writes it into simulating live drive into this database. It's a bit confusing maybe that we use an OVDS that was really mentioned to develop to be used in the cloud, and that is its main purpose. But we found out that once we had an OVDS database populated with vehicle trip data, that vehicle trip data could be replayed and thus simulate a trip, and then be written. The live simulator reads the not only the values of the signals but also the timestamps of the signals which are found in the database, and then writes it into the state storage in the pace given by the timestamps. So this is how we simulate a vehicle and a trip by a vehicle. The software that we use that is used in this demo comes from it's all found on open GitHubs, and it's these 4 GitHubs where you can find all the data, all the software that is used in this demo. We also, I think it was worth mentioning that not only this demo does not only build on the software components, active software components in the stack, communication stack, but there is also a number of data containers that works as buffers, you could say, and also configuring which data that should flow in from vehicle to the cloud. We have a file that contains the VSS tree in what we call a binary format that is defined on the VSS repo, GitHub repo. This file is used by the VSS tree parser, and that parser is used by the VISS server to, for example, verify that the path that is comes in a request from a client is actually found in the vehicle, and then of course in the tree first. If it's in the tree, it's in the vehicle. Another file that is used is a file containing a JSON array of all the VSS tree leaf nodes. This is the entire tree, which contains the tree structure. Here's just a flat array of the leaf nodes, and it's used, for example, by the OVS client to configure it which signals that it should retrieve from the server and then write into the OVDS. We also have two databases, which are both SQLite databases. Could be any other format, but we use SQLite here. One that sits as a buffer storage in between the VISS server and the underlying system, and it contains just one entry of a value and timestamp for each for all of the leaf nodes in the tree. So it doesn't contain any time series of data, but just the freshest, the latest value of each leaf node in the tree. And the fourth one here is another SQLite database that contains time series of vehicle data and can also store this for multiple vehicles. And this is, of course, the OVS database that sits in the cloud. This could have any name. The others must have these names for the software components to recognize them, and they must be typically in the directory of the software component, or sometimes it's addressed at the startup of the software component. It can be at other places. So this first one is generated by the tools that you can find on the VSS tools repo, and it comes from the official VSpec files. And this one, the array, is generated by the server at startup. So to generate this, which then needs to be provisioned to different software components, you have to start this server once and then maybe stop it again and do the provisioning, and then you can start the real demo or running of this functionality. And the third one, the state storage, is generated from this flat JSON array. So you need to generate this before you can generate this. This one is generated by the start of the OBS server, and it doesn't assume any VSS version, so it can contain any paths. And not only the one that this binary file defines. All right, having said this, so I think it's time to go to the demo itself. So we'll start up the OVS server that then creates the database, the OVS database, and we'll have a look in this before it's starting to get populated. Then we start up the OBS client that will run the WebSocket subscribe protocol, and we'll also start up the VISS server and the underlying live simulator on the same computer, so that we can also see the logs from this. Then later on, when we go on with the other OVS clients here, they will communicate with these servers on different computers, but then we obviously cannot see the logs windows. I cannot record that easily, so we'll not see that here, but we will start with everything on this computer. Before starting it, however, I just want to show the different data containers that we use here. We have the in the VISS server core directory, we have the binary tree file that the server uses to verify that the paths being sent in by a client is actually found on this vehicle. We have also in the VISS server service manager directory the state storage that acts as a buffer between the server and the underlying live simulator that will run on the same computer here. So we will have that here. And the client that we will start up uses the VSS path list.json file that the VISS server generates at startup. I've done that before, so we generate it. And sorry, as the binary tree contains the entire VSS tree, we'll actually get a quite large file with about 1,500 leaf nodes. And as the trip data that we are going to use in this demo is only 3 signals, the lat, long, and speed, I've reduced this file to only contain these 3 signals. Otherwise, the client would try to retrieve all the 1,500 signals from the VISS server, and it would only get in each iteration 3 back. So it's a waste of time, if nothing else. So just have a quick look in here. We see that we have the latitude signal, the longitude signal, and the speed signal in here. So we will start the OVS server and ask it to create this database, which is it did, and we can see that it shown here in the SQLite DB browser that I'm using to check what's in the database. So we'll look here. We can see that we don't have any VIN number still in the database, as it has not received any request from a client to write in any new vehicle data in it. So it's empty, and we could also see that there are only these 2. This table is for attribute data, static data, and we will not populate that at all in this demo. But we see that the table for the dynamic data, the time series data, is not yet available, and that's correct. That's how the OVS server starts up, because it hasn't received any VIN to write. So we will see later on that another table will emerge here. So here we have the 5 different programs that we will use in this part of the demo. We have the OVS server controlling the cloud database that we started earlier. We have the VISS server that we can now start. It tries to close down itself first, and then it's starting the 7 different programs that make up the VISS server. This is just information that it indeed runs 7 sockets used within it or by it. And here we have another OBS server, the one that will be used by the live simulator. It's an instance of the same as this, but started with one more parameter at startup, telling that it should use a different port number than over here, so that they don't clash. And this port number is, of course, known by the live simulator when that starts. This is the OVS client that will read from the VISS server on this address and write to the OVS server on this IP address, both the same and the address of this machine. It will create a VIN number called geotab2 in the database, cloud database. It will use 2 seconds to scan the VSS path list file that it reads to see which signals it should work on, and it will use subscription, VISS subscription in the calls to the VISS server. So let's see, we can now start that one. It subscribes to this, and then we'll also start the live simulator that started to read from this one. So this is some, and we can see that the client here is reading, just going on every 2 seconds. It will now, it's actually the VISS server that pushes, since we have a subscription, and it will receive it and write it into the database. And the live simulator is following the timestamps and goes to sleep every now and then between writing some stuff into the state storage that is used here. So this has been going on for a little while now. I think we should have new data in the cloud over the years, so we'll have to regenerate. And indeed, we now have a GENIVI VIN number here, and we have a new table called TV1, and the one comes from this index. So, and in this one we have now data, lat long and speed data for the timestamps that when it was actually captured from a real vehicle. And this is the real vehicle data that we are now simulating and replaying with the live simulator. So it seems to work so far. So this time we'll try to run the OBS client that uses the HTTP GET over the VISS protocol to retrieve data from the server down here. This time this server will not run on this computer but on another one, so we will not have as many terminals open at this one as prior. In fact, only two. We have OVS server that controls the cloud database, and we have the client that will run the GET requests, and it will address the VISS server on this machine, and this is the IP to this machine. That's to another machine, and to this machine that is to this OVS server, and it will use a VIN number, GENIVI1, and will iterate over the three signals in the VSS path list.json file over 2 seconds, and it will use the gets instead of the subscribes as before. So let's see if we can get this to run. Then we'll start that, and we'll start this one, and we'll see that it goes through cycles of the three signals every cycle, and we see that something is written into the OVS database coming from this server on the other computer that I have here. So let's see now if we go to the SQLite browser and we update here. Let's see if we have. Yes, we have now one more GENIVI1 VIN number with index 2, and we have one more table, TV index 2 table, and we have indeed also data in here, lat long and speed data from this other. It's actually the same data that is rerun in both simulations, but nevertheless this is logically linked to GENIVI, the other GENIVI VIN number. So let's try to run the third client that is running VISS over MQTT using a small helper protocol. And again, we're running this VISS server on the other machine, and on this machine. If you want to learn more about this helper protocol that is used to transport VISS version 2 over MQTT, you can find it on this GitHub project in the MQTT manager directory. There is also a sequence diagram to help understand it. Also, please be aware that the state storage database that is used by the VISS server now on the other machine must have the correct VIN number that you will use, as it's part of this helper protocol. It's an explicit parameter in that, so you have to, that has to be written into the path in the state storage database, the VIN path, for the VISS server to retrieve it and use it in this helper protocol. So don't forget that if you want to run this. Now, let's say on this machine now, we only have these two, the OVS server controlling the cloud database, and this time the MQTT client running this VISS over MQTT, and it talks to the VISS server on this other machine and to the OVS server on this machine. And it will write VIN number JTAP3 into the cloud database. It will scan the list of signals every 2 seconds, and it will use this topic name as part of this helper protocol that needs a specific topic name for the protocol to work. So let's see if we can get this to run. We'll start it, and as we can see, it starts to write into the database here. Let's give it a few seconds to run. So it retrieves data over MQTT and over the Mosquito broker up in the real cloud from my other machine. So all right, now we have populated, hopefully, the cloud database, this one, and we'll update and refresh, and yes, there it was. And we now also have a third table for this one with the same set of signals and actually the same values also, since we are reusing the simulated vehicle data for all simulated vehicles. But nevertheless, we now have all 3 vehicles in here with time series of data for these 3 different vehicles. So I think this concludes the demo. Thank you very much for listening.
Okay, thank you for that demo, Ulf.
Sure.
Let's see if we can get right picture in place. Thought we just have this picture in as a support for any discussion. It's the same image, slightly updated. One thing I was thinking about, Ulf, was the usage of the SQLite. We've had some discussions about replacing it with a more full size database, possibly a time series database. What are the required changes in the code in order to do that, if we want to do it?
Well, I think if we change to another relational database, the changes in the code should definitely be minimal. If we change to Postgres instead of SQLite, I think you basically point to a different library, and maybe they have slightly different dialect, so to say, in the request to the database, but it should be very minimal.
Yeah.
If we change to
a completely different, a non-relational database, I would guess. I've not really worked with such, so I don't know too much about them. Maybe it will be somewhat more, but that should be absolutely possible to do.
Yeah. Okay. Yeah, I haven't looked at the connections, but I think for something like InfluxDB or some database like that, there should be libraries and bindings available, probably for Go language.
Yes, I would think so too.
It's quite popular nowadays, so a lot of those things are in place.
Right, and as you have mentioned before, Gunnar, this replacement is particularly of interest in the cloud.
Yes.
Where you will have higher performance requirements than the database, the state storage in the vehicle, which is only used by one vehicle. The other one can possibly be used by multiple vehicle or vehicle clients writing from multiple vehicles into it, and so there's a possible performance bottleneck in the vehicle. It might be that the SQLite is good enough, right?
Yeah. Yeah, agreed. And you also have the multiple timestamps in the collected data in the cloud. So that's where the time series database is really useful. They usually have, features like filtering out the data when it gets too old, so that it keeps not every data point, but maybe if it's 3 months old, you keep only, 1/10 of the data points or whatever you set up, and so you can sort of get that automatic filtering on old data if you like, and a lot of other features like that. So that makes sense, mostly when you start collecting a lot of time series data. So yeah, okay. Well, that's good. I also wonder if anyone else has questions about the demonstration and the setup here. You can just unmute, or you can send it in the chat if you prefer.
I have one comment myself, and that is that there's one thing missing right now out on the GitHub repos, and that is the OVDS data that we use for the simulation. But I will add quite simple, only like used here with lat, long, and speed.
Okay.
With data like that very soon. I've not done it yet, but you find, and once that is also there, it is possible for anyone to do the same demo as I've done here if they're interested.
Right. Okay, that's very useful to have some demonstration data available. Great. Okay. Any other questions on the demonstration today? If not, then I think we can wrap this up fairly soon. Of course, some of these ideas about how this can develop were on the previous main workshop we had, when we talked about how to apply this on various cloud solutions, and a lot of those platforms, AWS and IBM and Google and Azure, they have ready to go services like this. Some of them have, for example, time series databases available. So that's another option to integrate with one of those existing APIs. And some of those details were described there.
Hi, Florian again. Maybe quickly to Ulf. Thank you very much for wrapping it up, full demo. On the OEM cloud part, did you actually develop all the identity management and authentication management as well? Is there also an implementation you developed, or is it just you on?
Well, I have only been involved in the implementation of software components in the stack from the state storage or also the live simulator sitting below it and up to the OVS cloud. So the other cloud components in this architecture drawing here with components like what you mentioned, I have not been involved with, and I don't think we have come that far with actually implementing those parts yet. Gunnar could help to clarify maybe on that.
Yeah, sure. I think there's only been design discussions on the access management, identity management parts. However, we have had implementations if you go further left in the picture. We demonstrated previously an example application, a mobile application using the GraphQL protocol to access data from that was collected in the OEM cloud. And seeing that you're an expert in the extended vehicle principle, you can see here that we are reflecting that, but we also set up just for evaluation. We set up a direct line between third-party services and the OEM cloud, not going through the neutral server marketplace, and that's an alternative that we think we may see, and it's interesting to evaluate what technologies would be used there if that direct connection is there. Otherwise, the main route, as you know, is to have a neutral server that sort of collects information from multiple OEMs and is the manager of the access control for depending on which client has been allowed to access which OEM data and so on. So that's just an interesting detail in this picture I thought I'd point out, and that is actually what we have implemented and shown a bit of a demo on that third-party mobile application connecting directly to the OEM cloud. But as always, there's more to do here for sure in the full implementation of access management and access control. Access control, generally speaking, is fairly well implemented, I believe, Ulf, on the CAR2 OEM implementation, at least in the VISS protocol case, which is the one demonstrated here. But we don't claim that this is the one and only. The key here is really, first of all, general architecture. Secondly, evaluating the kinds of technologies that can be used, and over time moving to a firmer recommendation on what to use. And as I've pointed out also in the CVII case, when you build a full technology stack, there may be parts that are shared in the entire industry through the use of open source implementations, for example, but there may be other parts that are just specified by a requirement and design specification, and the implementations may then come from various companies, and so that is a complex landscape to sort of survey what exists and what is fully implemented. But that is a work in progress, I would say.
Yeah, I understand. Thanks for that additional comment. Yeah, was just curious. Like, don't get me wrong. Didn't want to raise up any requirements. Just from curiosity, as you said.
Yeah, of course.
See a lot of overlap
question.
on the left side, especially. I'm not expert on the part from vehicle to the cloud itself, but as you just pointed out, the architecture seems very similar. When we speak on the connection from cloud to any client. And maybe as a last quick question, you mentioned that demo on the third-party client. Is that available on your public resources as well? Somehow, like a video of it or anything? A recording?
Yes, I believe we have a video from our all-member meeting in October last year.
Awesome.
I'll make sure you get the reference to that recording. Anyone can find it if you go to the CVII homepage, where we have a lot of links. There should be links there to recordings of previous meetings and presentations. But I can help you find the particular point, because it is in the middle of a longer session. So, but we do have a recorded demonstration from that. Of course, it's 6 months back, so it's the state that we had at that time.
Well, absolutely fine. Cool. I guess I can make my way to it on your website. But yeah, good to know that it's recorded and accessible. Nice. Cool. Thank you.
Thanks, Florian. Okay, it's time to wrap up this session, and next up we will continue with the Android Automotive Special Interest Group workshop number 2. We will continue on the same WebEx session, so I will just make a pause here. And I see some of our Android participants have joined already, so let's wrap up this the CCS demo and discussion, and we will start in about 5 minutes with the Android workshop. Thank you.
Thank you.